Welcome back, ladies and gentlemen. Today we're going to talk about adding and subtracting numbers in scientific notation. So let's get right to it. The sum or difference, or find the sum or difference. Well, that means we're going to add, we're going to subtract, just to remind ourselves that's what it means, get our brains going, focused, so we can move ahead. Write your answer in scientific notation. Well, if it's in scientific notation and I want an answer in scientific notation, the quickest way to do that is to do the math in scientific notation. If you wanted to, you could convert both of these. And that's what I'm going to go ahead and do here. I'm going to go ahead and say 1, 2, 3, 4, 6, 0, 0 plus 1, 2, 3, and 8, 7, 2, 0. And those zeros came along because there's there, and there's that, and that's where those two zeros came from there, and the 1 0 came from there. And if I'm going to add these, 0 plus 0 is 0, 2 plus 2 0 is 2, 7 plus 6 is 13, 12 plus 1 is 13. And then I'd have to go through and worry about turning it back into scientific notation because it tells us we got to use scientific notation as my answer. So here's this decimal. I'm going to go 1, 2, 3, 4 because my factor must be between 1 and 10 and it can include it. So 1.332 times 1, 2, 3, 4, 10 to the 4th. And since I made it larger, it is positive, so this would be my answer. Now, I could go through all that conversion, or I can realize that because my base is identical, that 10 to the 3rd kind of gets put on its side, all by itself, because it's the same. And then I can take 46, 4.6. Sorry, my kind of hip hurt. 0.72. Oh, there we go. If I didn't run out of room, let's just write that X there. So here I get 4.6, which came from here, plus 8.72, which came from here, and I get 1.332, and then I just bring everything else down because that's this, and it just comes down times 10 to the 3rd, which, oh, sorry, I put that decimal in the wrong place. So let me rewrite this real quick. Sorry, this 8 plus 4 is 12, and my brain just automatically did something it wasn't supposed to do. So that's 8 plus 4 is 12, but 7.72 plus 0.6 is greater than 1, so we carry that over. And then I get 2 times 10 to the 3rd. I've got a problem. These aren't the same, and the reason they aren't the same is this factor is not between 1 and 10. But if I do move this guy one time over this direction, that means I'm going to add 1 to that 3, then I'm going to get 1.332 times 10 to the 4th. So I end up with the same answer. And if I hadn't messed up my writing and done it correctly, as you can see here, this took at least 2 to 3 steps. I mean, we converted, we added, we converted back. Here we just took our numbers and added them together, keeping our base, and we got our answer. So there was also a trick in here, because if you notice, we kept our 10 to the 3rd. We had to add 1 because our factor was not between 1 and 10. But we can use that same idea where we can kind of change where that decimal place is in changing the 10, or the power, down here on example B when we are going to find our difference. We're going to solve it this way using scientific notation down here in our subtraction problem. But what we should notice is that 10 to the negative 2nd and 10 to the negative 3 are obviously not the same power. They have to be the same power in order to add or subtract our factors as they are. But the nice thing about that is this basically means I'm going to move left 3 times. So if I just move it once already, then if I were to write 0.66 times 10 to the negative second is the same thing as 6.6 times 10 to the negative 3. Now, it's not in scientific notation anymore. However, it does have like bases. So I can use this to say it's the same thing as 3.5 minus 0.66 times 10 to the negative second. Now, when I do my math here, I'm going to get that's equal to 2.84 times 10 to the negative second, and I've got my solution. I could always check my answer by taking this and moving it 1, 2 to the right, so I get a 0 there. I've already moved it once here, so 1, 2 more times to equal that 3, 0, 0. So my numbers become 0.035 minus, and I got to line up my zeros, 0.0066. I wrote that 0 really small. I knew something was off. All right, so I'm going to put that 0 here because that would be there. So again, I'm going to try and count up. So here's 4, and we carry that, and then I get 11. So to get up to, that would become 14. So to get to 14, I had to do 8, and then I had to take 1 away from there. I get 2, and then I get 0 there because 0 minus 0, and I get a decimal here. And in order to convert that, I'd have to go 1, 2 times. So I'd actually be making my number smaller. So I know because of that, 1, 2, it's got to be a negative exponent. I did it twice. 10 times 2.84, and I'd be done, and I get the same answer. So I can do it by converting it into decimals, solving for it, getting a final answer, then converting it back into scientific notation. Or if I understand how I can turn this same number, writing it in not scientific notation, not standard form either, just kind of manipulating it without changing the value, just how it looks, I can solve it using scientific notation. Now go ahead and pause the video and copy what is on your screen into your notebook. Now that you're back, anytime you have to rewatch the video for clarity or to remember something, you need to write what you pick up into your notes. Use arrows, circles, shapes, pictures, whatever else you need to, but add it to your notes to make them yours. Last, ladies and gentlemen, when we're learning, it's about understanding the process, not about finding an answer. We'll see you tomorrow.